So what is the expected value? For a continuous random variable x, the expected value has the same physical meaning as in the discrete random variables. It is basically the average value that the random variable x can take. But how do we calculate the expected value for continuous random variables? By integration. Remember, for discrete random variables, to calculate the expected value, we were summing up the potential values that the random variable can take multiplied with the probability mass function. So x times px values were summed up for calculating the expected value for discrete random variables, but for continuous random variables, as in here, we are integrating the product of x and the PDF from minus infinity to plus infinity. Actually, the mathematical analogy of the integral is called a continuous summation, right? So integral is somehow a continuous version of the summation operation. So instead of summation, we are doing integration operation here. And what do we integrate? In order to find the expected value of x, we multiply the potential values that the random variable can take with the density function of that values. However, because the potential values that the random variable can take are uncountably many, we cannot make a summation here. What we can do is an integration. So we are going to integrate x times fx to calculate this value, and the expected value is basically a weighted average of the possible values that x can take on. However, the possible values that x can take on are uncountably many, so we cannot simply take this weighted average by summation. And what is the weights of the potential values that it can take? The weights are the density values, the relative likeliness of the random variable to take on that value. So in order to calculate expectation, you definitely need to solve this integral. And let's do that for the first question, the simplest of these examples. We are going to find the expected value of x, where the probability density function of x is defined as 2x. So you see the PDF, remember, lowercase f stands for PDF, the probability density function. According to this PDF, the random variable x can only take values between 0 and 1. And if you intend to calculate the area under 2x, you can easily determine that it is equal to 1 because, again, this is a linear function. It has a triangular shape, and the area of this triangle is going to be 1. And the function is equal to 0 elsewhere. So I'm just going to do what? I'm just going to calculate the expected value as the question asks it. This is the definition of the expectation, the integral of x times the PDF from minus infinity to plus infinity. But then again, our PDF is equal to 0 anywhere else except the 0, 1 interval. And because of that reason, we know that this integral is going to yield us 0 value except 0, 1 interval. So what we are going to do is this. We are going to multiply x with 2x, which is going to become 2x squared. And we are going to integrate this between 0 and 1. Okay, and this integral is going to be 2x to the power 3 over 3 between 0 and 1, plugging in 1 and 0 values and subtracting from each other. We get 2 over 3, and 2 over 3 is the expected value of this random variable. There is a physical meaning of expectation as well. If you, my friends, draw the probability density function here, which is 2x from 0 to 1, it is going to have a triangular shape, right? And the weight center of this triangle is going to be at 2 over 3. So actually, this integral helps you to find the weight center of that function. And expectation is also found by that function. So let's try to find the expected value of another random variable. This time, the probability density function is given as 0 if x is less than 1, and it is 3 over x to the power 4 if x is greater than or equal to 1. So you see, our random variable x here can only take values which are greater than or equal to 1 because the density function is positively defined in that region. At anywhere else, it is defined as 0. And the expected value for that random variable is going to be the integral of the probability density function times x from minus infinity to plus infinity, just like in the previous example. In the regions where the probability density function is defined as 0, we are not supposed to calculate any integrals because it is just going to yield a 0, which is an ineffective element in summation operation. And in the regions where we have a non-negative probability density function, we need to multiply that PDF with x. Remember, the formulation is x times fx. And if you multiply x with 3 over x to the power 4, you get 3 over x to the power 3. So x's will cancel out. And if you integrate this function from 1 to infinity, the result is going to be minus 3 over 2 to the power x squared. And now we plug in infinity and 1 values here. If you plug in infinity in the denominator, you will simply get a 0. So the limit of this function at infinity is 0. And if you plug in 1, you will get a minus 3 over 2. 0 minus minus 3 over 2 becomes 3 over 2. So for this function, the expected value is 3 over 2. Now, my friends, if you want to check if you have done this calculation correctly or not, what you can do at least is this. You see, this random variable x can only take values which are greater than or equal to 1. So the expected value, the average value that it is supposed to take should be between 1 and infinity. Similarly, in the previous example, again, the random variable has the domain of 0, 1 interval. So the random variable can only take these values. Therefore, the average value that it can take, or the expected value, should be also within this interval. So let's move forward to another question. This time, the random variable x has the probability density function, which is partially defined between 0 and 3 as 1 over 4, and between 3 and 5 as 5 minus x over 8. Now, this is my probability density function. According to this PDF, my random variable can only take values between 0 and 5. Not just integers, not just rational numbers, all possible real values it can take. And at anywhere else, the PDF is 0. So the question asks us to compute the expected value. And the expected value is what? By definition, it's the integral of x times the PDF from minus infinity to plus infinity. However, the PDF is only defined non-negatively within 0, 5 interval, and between 0, 3 interval, it is equal to 1 over 4. So between 0, 3 interval, we are just going to integrate x over 4. And between 3 and 5, we are going to multiply the PDF with x, which will give us 5x minus x squared over 8. And the first integral will give you an x squared over 8. And the second integral will give you a 15x squared minus 2x to the power 3 over 48. Now, my friends, we are just going to plug in the boundaries of these definite integrals. 3 and 0 here, which will produce you a 9 over 8 minus 0 will simply be 9 over 8. And the second integral will produce 125 over 48 if you plug in 5, and 81 over 48 if you plug in 3. And the difference, when it's summed up with 9 over 8, gives you a 49 over 24. So what is the approximate value of this ratio when you divide 49 over 24? It is a little larger than 2, right? And you see the expected value, the average value that this random variable can take is a little larger than 2. It is not in the middle. According to this relative likeliness function, this probability density function, the average value that this random variable can take is a little larger than 2.